1999, question 1c. We're asked to show that if x squared plus bx plus c is a factor of this here, well then we get these two results. B cubed is p and c cubed is p squared. Now there's a shortcut to this question. If you spot that this x cubed minus p here, x cubed minus p is very like a formula that we're supposed to know, and that formula is x cubed minus p cubed. Actually, we won't call it p, we'll not get mixed up, we'll use the y in the formula. So x cubed minus y cubed is equal to x minus y into x squared plus xy plus y squared. And if we apply that formula to what we have here, which is x cubed minus p, we can rewrite x cubed minus p as x cubed minus the cubed root of p cubed. Now that might seem awkward, but we're just writing it like this to make it look like the formula, because that will lead to a shortcut. So if you sub in these two values, we get x minus, instead of y we have the cubed root of p into x squared plus x times y, which again is x times the cubed root of p, plus y squared, which is the cubed root of p to b squared, because y is cubed root of p. Now the reason I did this is because just by being alert to formulas and so on, I spotted that what's in the bracket here is quadratic, and we're actually given the quadratic factor here. So in a so to summarize, in a cubic function like x cubed minus p, if we have one quadratic factor, we have one factor on its own like this. That's always the way it works. So therefore this is the quadratic factor which must match up with this one here. So if I just match up underneath and put my x squared plus bx, we'll write it as x times b, just again to make it match up, plus c. And now it becomes very easy to finish, because just by corresponding we see that the b corresponds to 3 root p. So I should say the cube root of p. If we cube both sides, we get b cubed is equal to p. And that's part I proved. And part 2, again by corresponding we see that c is equal to the cubed root of p to b squared. And we can rewrite that for a second as, I suppose, cube root of p is p to the power of a third. And there's a square outside, which is p to the power of 2/3 if we use our rules of indices and multiply the powers when there's brackets. And finally, cube both sides, c cubed is equal to p to the power of 2/3 cubed. And the 3's cancel and you just get p squared, which is result number 2 here.